All right, new topic. Let's look at another reaction that causes people to think hard, and that would be the hydrolysis reaction of acetals. Acetal hydrolysis means that you're breaking it down into its original aldehyde or ketone, resulting in also the formation of two alcohol molecules. Hydrolysis, in its simple definition, is the splitting apart by adding water. In most reactions that we'll see in this course, you'll add hydrogen to one side and OH to the other side of a bond. It's a good thing to look for. So breaking apart the acetal means it's going to go back to where you began. It took an acid catalyst, H+, to put one together, and so you're going to need one to take it apart. And it takes practice to look at these and see where things are going. So with patience and practice, maybe you'll figure it out. So in our water molecules that are being used here, they're going to turn into OH and hydrogen on parts of your alcohol products. And hopefully you can see that the carbon and oxygen from the acetal carbon itself become an aldehyde or ketone. And, whoops, back up. And then the R groups from the two ethers are the R groups of the alcohols that are resulting as you hydrolyze the compound. All right, now let's look at some examples here and see if we can figure out how they work and see where the carbon groups go or where they come from. On the top, we have two ethers on the same carbon. That would be an acetal, right? I'll label it. And the acetal, in the presence of water and an acid catalyst, can come apart. And so the two alcohol molecules are going to have the same carbons as the ether linkages. And the carbons of the acetal that do not include the ether linkages become the carbons of your aldehyde or ketone. In this case, this is a carbonyl with two carbons, therefore it is a ketone. The second example on this slide has two ether linkages to the same carbon, and the ether linkages have two carbons this time. And so those result in forming two carbon alcohols, namely two of them. Ethanol is its name, no surprise. And then keep track of where the parts are coming from and going to. The rest of your acetal, another acetal down here, is just a couple of carbons and a hydrogen after you remove two ethers. And those carbons become the carbons of, in this case, an aldehyde. Notice that there is a hydrogen present on that acetal carbon. That means it would be an aldehyde as a product. The example at the top of the slide does not have those. Therefore, it is not going to be an aldehyde, but rather a ketone. This is acetone, just to make sure you remember it. And this is acetaldehyde. Good to know. All right, and ethanol, no problem there. Ethanol and methanol. These are just examples. There are many possible ways to do these. Let's try some examples. Oh boy, and let's see if you can figure it out. So what we have to realize is what's got to come apart and what kinds of products are we looking for. So what aldehyde or ketone are we going to get if we hydrolyze this acetal? And yes, it's an acetal. This carbon has two ether linkages on it. I hope that's evident to you. And what alcohol are we going to get when we take it apart? So you have to have water and hydrogen ions. That'd be the acid. And that's another way of being written as hydronium, in other words. And in order to do that, we have to lose two ether linkages. There's not going to be ethers when we're done. When we do that, we have to leave one oxygen behind. So take that off and take off the other ether linkage. One of them comes with its oxygen and one comes without the oxygen. What you have to recall is that water is being used as hydrogen and OH. The OH portion in this diagram would belong on this carbon to turn it into an alcohol, so CH3OH. And the hydrogen could go, we got to do this without making it crazy, down onto this oxygen to turn it into a second molecule that is also an alcohol. Yes, they're the same thing. And so what remains is everything else that hasn't been changed by this process. So we have a benzene ring, which should have a circle in the middle for less confusion, a CH2, a carbon with an oxygen, and then two more carbons. Does that look right? I think so. And this carbon, oh, I forgot there's the oxygen, need that. And this carbon doesn't have enough bonds, the oxygen doesn't have enough bonds, it needs to make a double bond. And this is a ketone. If you had to name it, it would be a little bit funny. Let's call this one 1-phenyl-2-butanone. Wow, that is an interesting compound. Usually we don't name them, but it's a nice challenge to be able to recognize names for things. And the other products are here, methanol, 2 of them. All right, one example, let's do another. The more you see, the sooner this starts to make sense, I hope. Oh, more examples, 2 on the same slide. So let's see if we can work it out. I'll have to write neatly. The first compound is funny looking because it's in linear fashion and it just doesn't look right away. So this carbon in the center apparently is your acetal carbon because it's got 2 ethers on it. That means that we're going to lose 2 ethers and go back to a carbonyl plus some alcohols. So let's remove one of the ethers without its oxygen and take one of them with its oxygen and then see what remains. Remembering that hydrogen and OH are going to be used from the hydronium, and of course the acid catalyst is just what's needed to make this happen. Put the hydrogen here, it'll turn into an alcohol. Put the OH group on the other one, and you'll get another alcohol. So the alcohols that result are both 3-carbon alcohols, also known as propanol, right? And then what's left besides that? Well, this molecule in the center, or the fragment, what remains, has a carbon and 2 hydrogens and an oxygen. There's not enough bonds. Again, we're going back to an aldehyde or a ketone, and so the carbon should make a bond to the oxygen, no more atoms to add, and that becomes a simple molecule called formaldehyde. Formaldehyde, also known as methanol, but the formaldehyde is the more commonly used name. Some of these examples look really funny, but if you sort them out, maybe they're okay after all. All right, the one at the bottom of the slide, same idea. Let's see if we can pull these things apart. Noticing where the acetal carbon is, it's the one with the 2 ethers on it. You have to lose the ether groups in order to turn it back into its original structure and original components. And so let's do the same kind of thing. Let's take off this fragment of carbon here on the left without leaving behind the oxygen. And the ether linkage on the right, we'll take that one off with its oxygen and figure out what we have remaining. So we'll add water. Water, we're going to add hydrogen here and OH here. Remember, hydronium is going to be a catalyst, but the hydrogen and OH are added in 2 different places. When you do, guess what? We still have the same alcohol as in the first one on this slide, so I'm going to write it out a little bit differently this time. It's still propanol. I guess 1-propanol would be the more correct name, right? And propanol, then what else is, there's 2 of them. And what else remains? Let's try to draw it so you can see what's going on. So there's a CH and oxygen, and CH2, I pressed something, sorry. Try to make this legible, huh? So we have a CH2 and a CH3. Now, that's just drawing it the way it comes from the original structure, just to keep it from looking like I twisted it. So which atoms don't have enough bonds? Looks like the carbon and oxygen again. And so this one should have a double bond between the 2. This is an aldehyde in this case as well, because there is a hydrogen on that carbonyl, just as there was a hydrogen on, well, 2 of them, on the carbonyl there. So this one is 3 carbons as an aldehyde. We would call that propanal. That's all the more it takes to describe it. Okay. Hydrolysis of acetals takes practice. I hope with time you can follow the pattern, make sense of it, and begin to feel more comfortable. These are going to be important when we talk about carbohydrates. Everyone likes sugar. So good luck on your studying. Ask lots of questions. It always helps. And I'll see you in class.